This circuit you're looking at has the ability to absorb energy from its environment. That energy exists in the form of radio frequency signals, like those from mobile towers, Wi-Fi signals, and so on. The circuit collects that energy and turns it into electricity, which it then stores in these orange capacitors you see here. This is 100% true, and I'll be showing you all of it step by step in this video. Now, if you take a look, I've set the multimeter to the DC voltage setting, and it's currently at 0. I'll now connect this circuit to the meter's pins, red to positive, black to negative, and as you can see, the voltage is slowly going up. No external power source is connected, yet the voltage continues to increase. So how is this happening? Well, the point you see here is functioning as an antenna. It captures radio frequencies from the surroundings and turns them into electrical energy, storing it in the capacitors as DC voltage. Right now, it's only charging in millivolts, which is a small amount. We've reached around 12 millivolts so far, and we need a larger antenna for more. Since my body can also conduct electricity, it can work as an antenna too. Let's test that out. When I touch it, you can immediately see the voltage climbing much faster. We've already passed 160 millivolts. This happens because the surface area acting as an antenna has increased, and the effectiveness also depends on how many cell towers are nearby and how close they are. We're now hitting about 400 millivolts. Let's keep watching to see how high it can go. We just hit 6 volts and the rise continues. It looks like 1 volt is getting closer. And also, don't forget that some of the voltage is being lost across the diodes that are in the circuit. There are several diodes connected in a series, and they are needed to change AC signals to DC. Now the charging is slowing down. I was hoping it would at least reach 1 volt. You can see it's peaked around 889 millivolts, now it's at 900, and again it's picking up speed. Finally, we've crossed the 1 volt mark and it's still going higher. Let me remove my hand now, you should notice the voltage drop. And yes, as soon as I take my fingers off, the voltage quickly falls. If I touch it again, the voltage starts increasing again. Now let's look at my camera stand. At the bottom, there's a piece of cardboard. This is used to isolate the stand from the ground. This tripod will serve as an antenna. Look at this wire, I've attached a clip to one end while the other end is bare. I'll connect the clip to the tripod and the bare end to the circuit. Currently, the multimeter shows 0 volts DC. Let's hook up the antenna wire. First, I'll connect these wires, it's showing 53 millivolts. Let's fully discharge it first. Now, as soon as I remove the discharge wire, the capacitors start charging from 0 again. The wire is disconnected, and the charge is building, 10.8 millivolts and rising. Now I'll finally connect the antenna wire. Watch how quickly the voltage increases. You can see a fast rise in voltage after this connection. Let's see how high it goes. I'm not sure why, but when I touch the wires, the voltage jumps even higher. I'm really not sure why that's happening, but it's pretty interesting. Now we're at 1.7 volts, and the charging is quite fast. We're getting close to 2 volts, wow, that's exciting. I'll remove my fingers and again you can see the voltage drop. Something's definitely going on when I touch the wires. Let's push it further, very near to 2.5 volts now, while 3.5. But as soon as I let go, the voltage starts going down again. Something strange is happening with my fingers. Oh, now I understand. My body is acting as a ground, and when I touch the wire, it completes a kind of circuit. We're pulling AC signals from the environment and grounding through my body, which helps charge the capacitors quickly and gives them a proper polarity. So, for this circuit to work better, having some kind of grounding is helpful. Looks like we've stabilized around 4.5 volts now. Here, I'm going to try a small experiment. I've connected this tiny buzzer to the circuit. The voltage showing now is 460 millivolts. From this, we can tell that without a ground connection, the capacitors aren't charging efficiently. So I'll connect my body again as a ground like before. Check it out, the voltage increase is sudden. We've hit 1.8 volts. Now, when I connect the positive wire of the buzzer to the positive side of the circuit, we should hear a sound. I'll bring the mic closer so you can hear it. Here we go, it's slowly climbing, still at 4.5 volts, let's get a bit closer. I don't think the voltage will go much higher, so let's try. There you go, see the voltage drop when it connects. If I keep it connected, there's no buzzing, but as soon as I disconnect it, the voltage starts climbing again. Once more, let's connect it and wait a bit, let it charge, and now, go. The voltage dropped to 4 volts. Next up, I've attached this small green LED. I'll charge the capacitors again with my body grounded, just like before, and now let's test the LED. That should be enough charge. I'll touch the clip to the wire, go. A blink. Let's try again for those who missed it. This time, also watch the voltage drop on the meter, go. See, it fell to 1.945 volts. Now the LED isn't glowing anymore, it's showing 2 volts, which should be enough to light it up. But the brightness is very low. Let's touch this point instead, same thing. And now from another point, again, the same result. As you saw, this circuit managed to reach around 4.5 volts, which seems impressive. Some of you might be thinking, great. That's enough to charge a phone because phones charge at a similar voltage. But no, you can't run most devices with this, because the current it produces is very small. Now, coming back to the real reason I made this video, this entire setup is inspired by Maxwell Chikumbutso. A lot of you might know his name. He claimed to have built a machine that collects energy from radio waves and turns it into usable electricity, supposedly enough to power entire homes, around half a megawatt. Based on my own research, I don't think this is true. The kind of system required to produce that much power would be huge and just not practical. My circuit, for example, is producing way less than a watt, probably in the milliwatt range. So just think how hard it is to even imagine getting something like half a megawatt from a similar method. Another one of his claims is that he built an electric car that doesn't need to be charged and runs forever on radio frequency energy alone. Again, that's just not possible. Where's the ground? Without grounding, I don't think you can pull much power. And even with that, the hardware would have to be bigger than the car itself. Plus, it would still rely on strong radio wave sources nearby, like broadcast towers. So yes, it's a fascinating idea, and sure, it's like getting free power because you don't have to pay for electricity. But still, it's not completely free. What this circuit is doing is converting freely available radio frequency waves into a tiny amount of electrical energy. And that wraps up this video. I personally don't believe in the huge claims made about Maxwell Chikumbutso's inventions. His patents were rejected since they were based on ideas similar to perpetual motion machines, which are not accepted. As far as I've found, his house is still connected to the regular electric grid and he's paying electricity bills like the rest of us. So yeah, that's all. Goodbye. Let me know if you'd like it styled differently or used in subtitles, narration, or scriptwriting format.